Welcome everyone. In this video, I want to dive into Altair Inspire PolyFoam. And I want to look at what are some of the insights that you can get from running a foaming simulation. Now, polyurethane foam in itself is a really versatile material. It's mainly used in applications like insulation for refrigeration units or sound insulation, shock absorbent, and even pipe insulation. It will add additional durability and it will maintain thermal properties. It also helps you reduce the weight of the final product as well. Now, the downside of this is that the foam relies on a chemical reaction to create that expansion of the foam, which that in itself can be very difficult to predict. And that's where PolyFoam comes in. It really is an incredible tool for those that have to worry about incorporating expanding foam into their products. Now, for this video, the example I'm going to use is a piece of acoustic soundproofing foam. And there are 5 steps to running any PolyFoam analysis, and I'll go over those really quick before I get to the results. The first thing you have to do is import your CAD file. You have to define your nozzle and the path it's going to take. You need to create your mold and any of the other toolings. You have to define your parameters for that simulation, and then that's it. You can run your analysis. Okay, now on to the results. Now there are 4 main categories that the results are going to fall into. The first is the injection phase, which is exactly what it sounds like. It's the injection of the material. The second is the foaming phase, which is the expansion of that foam stage. The third is the curing phase or the hardening phase, and then the last category is the defects section. Now, if you select one of the phases, you have quite a few options for the results you're going to get. You can choose material temperature, allows you to review the temperature evolution during the different phases. You can look at the density of the material throughout the different phases. Then you can look at the polyol and the isocyanate, which are the 2 different compounds that go into making the foam expand. Then you can review the impact of pressure on your material. You can look at velocity, which helps you understand turbulences that might cause defects. Then you can also look at the mold temperature, just to make sure it's not getting too hot, which can cause the mold to degrade over time. Then the last few are, you can check the viscosity and just understand the thickness of the foam as the expansion occurs. You can understand airflow, which basically lets you view the behavior of air inside of your mold during the different stages. Then you can look at shear stress, which is kind of the forces that are being applied that might cause that part to deform. Now looking under the defect menu, we have a few different options. We can look at air pressure, which again can cause porosity or different voids in the material. You can look for surface defects like coarseness, toughness, or melting. You can look at shrinkage, which is always an important metric when the process includes injection. You can also look at weld lines, which is when 2 flows meet each other, and that can cause cosmetic issues or even structural weaknesses. So you can see from all this how beneficial it can be to run a foam simulation. Now, Inspire has other manufacturing solutions for metal casting, metal forming, additive manufacturing, or even polymer or metal extrusion. And these manufacturing simulation tools are in addition to the geometry creation, implicit modeling, photorealistic rendering, topology optimization tools, and all of those are the core of the Inspire platform. For more information, go to www.trueinsight.io.